Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today we are going to study a new problem, that is a problem number 5, which is based on exponential form of Fourier series. So first of all we'll see the question and then we'll move on to solution. So the problem number 5. Determine the exponential form of Fourier series coefficient of a periodic square wave. This is the square wave where the sample is present in between minus t naught by 2 to t naught by 2, and from t naught by 2 to 3 t naught by 2 the amplitude is 0. That's why this periodic square wave is considered as a pulse train also, or you can say a pulse train. Now in this function, that is in this x of t, we are having amplitude a, or you can say the highest amplitude of all the pulses or square wave is a, and we will solve only a one period value because our period is starting from minus t naught by 2 to 3 t naught by 2. So what is the total exact time period? The total time period is complete 2. So look at here. This pulse is available only in between minus t naught by 2 to t naught by 2. So I can say that my total period is t naught. Now we will use a definition of exponential form of Fourier series and we will substitute my x of t value in that. But first of all we'll discuss the equation of x of t. So, according to definition, the exponential form of Fourier series is represented by x of t, where the summation value varies from n values from minus infinity to infinity cn. This is the coefficient of exponential form of Fourier series, and it is multiplied with e to the power j 2 pi n, where cn is the coefficient of exponential form of Fourier series, and e to the power j 2 pi nt upon t naught, where t naught is the period of the given function. Now, what is the cn? The cn, the formula is integration minus t naught by 2 to t naught by 2, or else we will use t to t plus t naught, x of t e to the power minus j 2 pi nt upon t naught, and we are going to integrate this whole product with respect to time t, where my x of t is having amplitude a and it is available in between minus t naught by 2 to t naught by 2, and it is 0 in between t naught by 2 to 3 t naught by 2. So we will solve only this part because we have amplitude a in between minus t naught by 2 to t naught by 2. But here we have amplitude 0. So if we solve or if we calculate the x of t value in between this, your result is always 0. So we will solve only this part. That is, I'll substitute x of t value as a and my integration limit is from minus t naught by 2 to t naught by 2. Now, here I have substituted my x of t value, which is a, because the time period from minus t naught by 2 to t naught by 2, we have that amplitude a, and it is multiplied with e to the power minus j 2 pi nt upon t naught, and we are going to integrate with respect to time t. Now, a is a constant, so I will take it outside of this integration and we will integrate only e to the power this whole part, but with respect to t. Now we have studied one formula, that is e to the power plus or minus at. If you are integrating with respect to t, then result is always e to the power plus or minus at upon plus or minus a. So which means we are going to divide this whole function by value of a. So here my value is minus j 2 pi nt by t naught. So we'll divide this whole part by that a value. So we will divide whole exponential term by minus j 2 pi n by t naught. Now I'll take this whole denominator outside. Here I have taken this whole denominator outside, so we can write t naught upon minus j 2 pi n. Inside this bracket, what I have written, only exponential term, and I'm going to replace all this t value by upper limit and then I'll substitute lower limit, but I will place minus sign in between them. Now here t naught will get cancelled. Here I will substitute first of all upper limit, that is this t is replaced by t naught by 2, and then I will substitute lower limit, that is again this t is replaced by minus t naught by 2. Look at here. First of all, I have substituted the upper limit, which is t naught by 2, and then I have replaced this t by minus t naught by 2. So in the power, t naught and 2 will get cancelled. What is this remaining? E to the power minus j pi n, and here minus j pi n. Minus minus will become plus. Look at here. If I shift this minus sign inside this bracket, then this term will carry positive sign, whereas this term will carry a negative sign. We have studied one formula of sine theta, but in exponential form. Sine theta is e to the power I theta minus e to the power minus I theta upon 2i, where my theta is pi n. So we will substitute this formula, but the much more important thing is, we don't have here a 2j in the denominator. But look at here, at the outside bracket, in this formula or in this term, we don't have any value of 2j. But look at here, we have a 2j value outside this bracket. So we'll take 2j inside this bracket, and then you will get the formula of sine theta, where my theta is pi n. Now here I'll take 2j inside this bracket. And e to the power j pi n minus e to the power minus pi n upon 2j is nothing but sine theta, and my theta is pi n. Now, if I write sine n pi upon n pi, then it is nothing but a sinc x, where the sinc x formula is sine x upon x. Now, the Cn value is a upon n pi. Inside the bracket we have sine pi n. If I divide sine pi n by n pi, then we have studied one formula, that is sinc x. What is sinc x? The formula is sine x upon x. So if we divide sine x by its theta, that is x, then the formula is sinc x. My Cn value is now a upon n pi sine pi n. We have studied one formula, sinc x. What is the formula? Sinc x is nothing but sin x by x. If we divide sin theta by theta, then the formula become sinc x, or sampling of sin theta. Now here, my theta is pi n. Here also we have a pi n. So I'll divide sin pi n by n pi. What we have? Sin theta by theta, and this is nothing but my formula of sin theta. And this is nothing but my value of Cn, and I will substitute this Cn value in the definition of exponential form of Fourier series. Now I will substitute my Cn value in my exponential form of Fourier series. This is the standard definition of exponential form of Fourier series. I have substituted my Cn value, that is sinh theta, that is sinh n pi, in this formula. So this is all about the definition and the equation of exponential form of Fourier series, and this is our solution. Now we will solve a next numerical in next video. But for that, stay tuned to Ekeeda and subscribe to Ekeeda for further more videos. Thank you so much.